Okay, thanks for coming, everybody. Looks like we're everybody's starting to come in for this live webinar. Welcome to this Tuesday, May 26th webinar on custom sensors in RayStudio 3 software. What we're going to do today is while we did name it custom sensors in RayStudio 3 software, we're gonna talk about that certainly, but we're also going to talk about configurations and calibrations for all any numbers of sensors inside of RayStudio 3, and then there's because they're so related in how they work and how they come together. So we thought we'd cover a little bit more than just the custom sensor topic, but we will get to that as well. So I appreciate everybody being here. We're going to start off with just some quick things and some quick introductions to some of the folks that are helping us. Number one thing we always talk about here at first is if you have a question that you're looking for to get answered as part of this webinar, make sure you plug it into the question and answer box. If that's not open for you, push the little Q&A button on your little toolbar, and you can open that up, and you'll see that. If it's pertinent to this one and you want to try to get it answered by Matt or myself as we're talking today, make sure it's plugged in there. We have quite a few AIM employees and staff that are here working with us in the background. We've got Robbie from our California office. He'll be answering questions, and some of the questions you may type in there, if he knows the answer really quickly, they may one of the guys may type it in, and you'll see the answer there in the question and answer box. Some of them they pass along to us, and we answer. We also have Cameron from our Roanoke office. We've got Brick and Robinson from Roanoke. Of course, we have Emiliano here from Milan, Italy. He's here helping us as well. We appreciate all of those guys helping us, doing all the hard work behind the scenes. We also have Robbie typically handles it, but other people may link some things in there. You have a chat box as well. I see quite a few of you are already in there chatting back and forth, which is great. You'll see some links come in there occasionally that Robbie or the other guys will throw in there if Matt and I ask for those, and mention something that maybe if we want to link it real quickly, Robbie will take care of that. Make sure that when you're typing into that chat box, when you look down at the bottom where it says type message here, there's a to button there, a little pull down list, and if you just leave it like it's at, it'll just come to the panelist, just to me and Matt and the guys working in the back. They're answering questions. It'll just come to us. So make sure you hit that little down arrow and select all panelists and attendees. That way everybody will see your messages. You also can do some private messaging in there with some of the others and just send it to certain people, but most of your chat should be probably listed in the to box to all panelists and attendees. That'll help everybody see everything. You see Robbie up there is already sending out already sent out a link there to the YouTube page where we place all these recorded videos. So there you got an idea of how that works. Again, any questions you might have that you might want answered that are specific to this webinar or that you might want answered, make sure you put them in the question and answer box. Okay, perfect. And with that, we'll step up and we'll take it to the next level here and talk about Matt. I think this is Matt's third or fourth webinar he's been co-hosting with us, and he's a longtime AIM dealer of our products, and I've met Matt at any number of racetracks, and we've had a good time, and he's very knowledgeable. And one of the things I like most about him is the strong support that he gives across the board. So what I'd like to do is have Matt tell you a little bit about himself, and then we'll jump into the webinar. Matt.
Hey everybody, my name's Matt Romanowski. Like Roger said, a longtime AIM dealer. I pride myself on that I try not to let anyone ever out support me. Although with the guys we have on here from AIM, it makes it a really tough job. They are not even class leading in race cars or anything, but I think any product leading in their support. So I try to match that and beat them. I do seminars for folks at the track, coaching, support through the phone, computer, sales. I carry a ton of inventory. More on the other side of the room, and really just love race cars data, and I dream race cars when I go to bed. So doing this stuff is a ton of fun to get out there and help you guys kind of learn all the different ways that the data systems can help you out.
Perfect, Matt. Yeah, Matt's at racetracks or on the phone at 2 racetracks virtually all of the time. One of the things you'll notice here slightly different is my camera is not pointing at me. Because of the topic we're going to use today, and some limitations of my technical skills, I suppose, where I could not do 2 cameras. So I took my camera and I pointed it at a up and running MXP aim dash here, where when we get into doing some calibrations and some custom sensors and the like, we're going to have Matt will be running the software itself, and you'll see here my my hand comes in there. That's a live version of that little demonstration rig that we've got set up here with steering and suspension and throttle sensors all connected. So what you're going to see is us actually doing calibrations and configurations right live. So if that is a little small for you, maybe you can resize your window and maybe see that a little bit bigger when that time comes. But we're a little ways away from that right now. But just to give you an idea of what you're kind of looking at there. And the last thing I'd like to do before we hand over to Matt to start talking about custom sensors is I'd like to launch a poll. We do polls here to help us understand where everybody's at. And I know a lot of you are return viewers, and I know you've done some of these already. But we will have a new poll here today as well. So, but the first one is owned AIM devices. It's a big part of us understanding where we want to go with these webinars is based on the feedback that we're getting from you. And this is one of those things where we continue to look at these and look at the results and get a really good understanding of what's out there. The last choice down there happens to be SmartyCam and other. If yours is other, and that's the reason you're using that box, I would love you to go ahead and select it, obviously, and then up in the chat box, just type other dash and then whatever your other piece of equipment is. That helps us understand exactly where we're at as well. So I do appreciate that. Looks like a good chunk of you have voted, so we'll be closing that in just 5 or 10 seconds. So keep that in mind, and then that box will get out of your way, and we can turn this over to Matt. So I'm going to go ahead and go to the next screen with this, and then and you can start to kind of look at where Matt's going to start. I'm going to go ahead and end that poll, and then I'll work on giving, let's see, do that, and then I'm going to give remote control to Matt of the mouse, and Matt should be able to take that over. And looks Perfect. Like he's got it. And there you go, Matt. Start on the presentation. And again, questions and answers into the question and answer box. Matt and I will kind of keep our eye on those, and we'll see where that takes us. Go ahead, Matt.
All right. So I want to kind of start with kinds of sensors. And part of a sensor is that with AIM, when we're working with a sensor, it's putting out between a 0 and a 12-volt output. And that voltage gets converted in the hardware into a value for us. And it could be a pressure, it could be a temperature, it could be a distance, any of those things. So up on this slide, I put a bunch of different sensors. And in those sensors, the front and center is a pitot tube. We've seen it on F1 cars and all kinds of LMP cars. I put that in the center because me personally, I really want to put one on my 914. I just haven't been able to justify it yet. I joke I have the only 914 in the country that needs a computer to start, and I figure a pitot tube is got to get on there pretty soon. The other sensors we see on there are all different ones. So I have a range that I grabbed on my desk. Here we have, it's an inch square, maybe a quarter inch thick. It's an accelerometer. It tells you the G-forces that you could mount on your car. One of my favorite sensors from AIM is the 10-inch string pot. We'll talk about some different ways these get used and all the different applications for them. And when you get really creative, it's a great sensor. Sometimes this is more of a go-kart sensor, but a push position sensor. Usually they're about 150 millimeter stroke. A great sensor to use on a pedal. You can see this one, somebody made up their own with a little mount here that you can do different things with it. We have pictures on there of the rotary sensors that the sensor gets hard mounted and then gets moved around the center axis in a rotary way, and it can be used for a throttle position. On some cars, this could be used for a suspension bell crank movement. Another rotary kind of sensor is the gear type. I used these 20 years ago for steering positions because you can put a little pulley around it and turn it. One of my favorite sensors that I do a lot with is linear pots, and they move in and out like a shock absorber, but it measures the distance in it. And there's all different lengths from 50 millimeters to, I think we can get 300 millimeter ones for like an off-road truck. That was an AIM one. This is a different brand, but the same idea, right? In and out, puts out a voltage for us. Another one that we use a lot is temperature sensors. This is a standard kind of GM temperature sensor that we can put in to the software to do things. All different kinds of ways to do it, but we can get different things out of them. And I see some of the questions popping up about these is resolution in the sensor. Well, the easy way to answer this is the more range of a sensor we use in that 0 to 5 volt is the more range of the output we get, because that's analog signal. The 0 to 5 volts gets converted to a digital signal, and then it gets put through to the positions or other things through the analog to digital converter. Gets a little bit more in depth than what we're going to see here, but the more voltage range that we have, the more resolution we have out of it. Some really good questions I see popping up, things about fuel flow sensors. Another great question, if it outputs a voltage, it will follow through here just like we're looking at. Another one about voltage, if we can take 12 volts, that's when the systems can take in the 12 volts. Most sensors are 0 to 5. We can work 0 to 12. And then ask if the voltage drops below 12 volts. Well, that comes down to a sensor question, that if how sensitive the sensor is. Many sensors are only a 5 volt input, and we have that in the wiring as well. So it's kind of specific. And then this is a question I was going to touch on later, but I think now is the perfect time. Someone asked about tire temps and how you can do a custom sensor for that. One of the really great things about AIM is their sensor library and the sensors that they manufacture is huge. So we have all of our pressures, all of our temperatures, all those kind of things are already set up in the software that we don't need to create those sensors. So it's a really nice way that makes our job doing this kind of custom sensors much, much easier to work with. And then someone asked about, the temperature sensor I showed is, they ask, is it better to configure a Bosch one or a GM one? Many times they're the same. The more important thing is to make sure you can get a sensor table for that particular sensor to be able to put in. So already some really awesome questions that we have going here. And I think this is gonna be fun as you guys see some of the different ideas that I have with custom sensors. So here we have a picture, just a whole bunch of different ones. When we hop over, the next part that makes everything else much easier is the idea of the calibration. So calibration is when we take the value that we're using and we say, this is what it actually means. So if it's a position, we put it to, is that 1 inch or 2 inches or 3 inches? Is that 1 millimeter? Is it 1 centimeter? If it's a pressure, is it 5 PSI or 500 PSI? Is it a bar? What are these numbers? In a G sensor, the one I showed like this, that your dash has a sensor in it if you have a dash. But then using that, we can mount those in different spots on the car if you want to do some really advanced kind of analysis. Using those, we need to tell it, is this 0 or not? So in it, we have something that's called the auto calibration. That's one where we have a table for the sensor that says the voltages, and all we're doing is telling it where 0 is. So the idea of using it with an accelerometer, if it's not perfectly level, it accounts for that little bit of perfectly level. That's really what the auto calibration does, is it sets it to the 0 point to where we are now. That's the idea to take away from this. The other calibration that we're going to calibrate it is for something like a rotary pot, where we have an arm that turns. And think of this as something like throttle position or steering position, where we want to know, is the wheel straight or is it turned? And that's individual to your car, not the sensor itself. So those, we're going to tell it positions along the way, and it's going to fill in all that other information for us. And if we can use the idea of how these calibrations work, then the rest of the mechanics of setting things up becomes so much easier. Couple questions that are popping up here. Someone said, is it applicable to a Solo 2? That's one of the devices, along with a Solo, that it's not applicable. You can't put a custom sensor into a Solo 2 because it doesn't have the analog inputs, but an MXM, an MXL2, an MXS, Evo 4, Evo 4S, Evo 5, all those ones you can do. All different ways you can work with those. But in the Solo range, at the base line, the beauty in those devices is the simplicity, is all the GPS power in them that you don't have to do the other things.
Matt, there's one there on sampling rates. Can you just touch upon it a little bit? I've got a document that we will place up in the in the description box on this YouTube video, on this webinar when it gets onto YouTube, where I have put together a little table where a number of different experts in the field, books that are out there, talk about what sample rate should go with which channel. And then I've put together kind of an AIM suggested sampling rate table. So I'll put that up there in the description box in the later today for everybody to download. But Matt, if you want to chat a little bit about sampling rates, which is what was one of the questions.
Yeah, so sampling rates. A really great question. And there's some generalities, and then a lot of it comes down to what we're looking at. So things like temperature. I look at that and I go, how fast is this temperature really going to change? And if it's a oil temp or an air temp kind of thing, you go, it's not going to change really quick. Like once a second, that's probably fast enough, 1 hertz. Something like a suspension position. Well, these, we want to go, I think Roger's document starts at 200. I kind of subscribe to the idea, I go 500 or more. The new AIM hardware and the MXL2s, the MXS, the MXP, these devices have a ton of memory, a ton of throughput ability. So there's no real downside to logging faster, in my opinion. Some people will tell you it creates extra information. It can create some challenges if you have a, say, 100-lap race with shock pots, 4 shock pots all at 500 hertz. That is a lot of information. Your computer might crunch a little bit to do some math with it, but I don't think it's too big of a problem. And then things like if it's a throttle position sensor, back to one of these rotary sensors where it's how fast you hit the gas and you let go. Those I'd say 20 to 50. There's some great answers in a lot of the books and a lot of different ways to do it. But it all comes down to kind of what you're looking at. And to get really deep into it, you start looking at different problems in the data and the signal and how it combines. But I think Roger's document's got it good. But I look driver inputs, I'd say 20 to 50. Chassis things like suspension, 200 to 500. Temperatures 1 to 5. And then pressures are really a range being... it depends what you're looking at. If you're trying to figure out how well your oil pump works, you might be looking at 10 to 50. If you're just kind of a regular car, you're not too worried about it, you just want to make sure you monitor it well, 10 is plenty. So hopefully that gives you a little bit of an idea.
Yeah, it really does vary for the use and the person that's
right.
doing it, right? To your suspension example, if you're using your suspension pots for maybe to look at some aero lifts at high speeds and things like that, right? It's really looking at pitch, roll, yaw of a car using the shock pots. 200 is way more than sufficient. But if you are taking that data and you're going to go take it into into some simulation software and it's looking at it at 1,000 times per second, to match up to some NASCAR style, track modeling where they're looking at a lot of simulation things, that's looking for it at 1,000 samples per second. So that's what would be important to that person. So it really does vary on the end user's need as well. But the the range that you just gave is pretty typical. So, and we'll have that document up there that talks a lot of different users, and maybe we'll throw Matt's some of Matt's suggestions in there before I put that up there. So perfect, Matt. I enjoyed that.
Yeah, and I think, Roger, if we have before we kind of jump into actually setting up some sensors and going through some things, maybe we can throw that other poll up and find out what people are using custom sensors for, and if they're using any of them, if they're using these. So you can see here we have are you using throttle position, a suspension travel, steering position? Are you making up maybe your own temperatures? A really popular one we're going to look at the end here is fuel level. Comes up all the time. There's a couple different ways to do it, and I think it'll be something that'll be interesting to hear. Pressures, custom sensors, we don't see them too often. We see them more when maybe somebody brings in a sensor from a different brand or is converting into something like that. So
or
it'll be really interesting for me
or even a pressure sensor off of a car that you know is there and it's got some outputs and you just want to tap into it instead of adding your own sensor. That's very typical, right?
Yep.
So and everybody's voting, and it's looking pretty well here. Is in a few more seconds, what we'll do is we'll end that polling and we'll share it, and give everybody an idea of what that looks like. We're about 65% of you have voted already. So if you in the next 5 seconds or so, we'll end that poll, and have everybody take a look at it.
And one I see here is someone said we're missing brake pressure in the poll. Click pressure, because if you're using a custom sensor and pressure, we're going to look at that example at the end, towards the end here. And I'm going to show you a really neat trick that I think is going to help a lot of people out with sometimes when they have a problem.
Okay, let's end that poll and let's share the results. So let me do that. And there you go. Again, for the benefit of folks that are watching this later, this box does not show. So the number one was 48% of you mentioned that temperatures sensors are some custom sensors that you have worked with a little bit. It looks like the next one is pressure sensors, probably thought about as far as from Matt's comment on brake pressure. That's a big use of it. And the next one after that is throttle position, and we're going to do a throttle, steering, and suspension sensor calibration here in just a moment live. So steering was the next at 36%, and the other one that's in there that is kind of interesting is no, I have not used one yet, which is a very valid answer, and that was at 30%. So we've got some folks here that haven't played with this feature too much, and we've got any number of folks that have looked at it quite a bit. So we'll try to give you some tips and tricks, and also help the folks that have not looked at it at all. So perfect. I will stop sharing those results. And Matt, you want me to jump out and into live data?
Yeah, if we jump into Race Studio 3, okay, I think we can jump into our first one.
And Matt, you should have control. You just have to click once so everybody can watch your cursor move around. And then and Matt, you're going to drive, and I'm going to run this demo rig over here as you get to that point, as we start to do some different things. And Matt's going to walk you through some different calibrations, some different setups in the configuration.
Perfect. Now the only thing I didn't plan for is if I have to call Roger Vanna or Roger.
Yeah.
So as we jump in here, we can see that we're starting with the same LearnFast seminar that we had last time. It's the same dash setup that we used, and we hop this time into the Channels tab. And in the Channels tab is where we get to configure all the analog inputs, which includes our RPM, our wheel speeds, the channels 1 through 8, the analog channels that go straight to the dash, our accelerometers, gyros, GPS accuracy and speed, altitude, odometer, and the brightness of the dash. So even if you have a dash with nothing added onto it, you have all this power in it to start. So the first one we're going to jump into today is steering, because it's one of the most critical things if you're looking at driver inputs, is you really want to have that steering. So when we click on a channel to set it up, and all I did, I clicked the box instead of the channel to open up here, is we get our channel setting box. This is where we can come in, we set a name, And here we called it steering. I try to, if you're working across multiple cars, try to keep your names consistent so the analysis part goes better later, and even make yourself a little list of, I call it steering instead of STRG or something. Makes your life later much, much easier. It's an analog sensor. And then our function that you see here is steering position. And the way we get steering position is we're going to say angle and then steering position. And the way I remember that one is steering position is an angle, right? It's how far you turn the wheel from level. The next one is we're going to call this, and this is why we went through the calibration ideas and schemes, is we have to pick, is it an auto calibrate, like an accelerometer that we're just going to say here's 0, or are we going to set it with points? And angular pot calibration lets us pick extreme kind of left and right, or turn in at angles. So we're going to pick the angular pot calibration. Our speed, we have it 20 here. Maybe for your steering, you want 50. Some of the books mention 50, some mention 20. Kind of pick where you want and what works for you want. Our unit of measure is decided for us because it's angle. It's going to be degrees. And then the display precision. With the precision of what we're picking is you go, I always think through it as a driver. And I say, when I'm driving, do I want to know if I turn the wheel 90 degrees or 90.1? Is that something I can replicate? Is it something I can really think about? I go, I can think 90 or 95. I can't really consider 91. So I pick 90. Or I pick the idea of 90 degrees, and then I pick no decimal places. This one, as Roger and I were talking about the seminar a little bit, is the last point we have down here is this idea of total potentiometer travel. This is not a hard, steadfast limit. It's not when the sensor gets to necessarily 180, it's going to stop reading, unless you've reached mechanical limits on the sensor. So it's one where you pick the appropriate kind of range that you want. So in a car on the racetrack, you're not going to turn the wheel 300 degrees to a side. You might not even turn it 90. I told Roger I usually pick 90. He likes 180, but pick a value so when you go to do it, it gives you a good range that you can duplicate. Don't pick 37 degrees. You're never going to be able to pick 37 as you turn the wheel to calibrate things. So as we set up the sensor, we go through these boxes, we select as we did, and you're going to say save. Now you've set that up. So when you plug your steering position into channel 2, and we see that right here, and you transmit it to your dash, you're going to have that set up for channel 2 is going to be your steering position. And then if we hop over here into our live measures, and something that sometimes gets people is when we're connected the computer to an AIM device, up here where it's bringing you in is the double arrow. And when that's green, we're connected to a device and we can go in and see our live measures. So what we see now is Roger had highlighted our 3 channels. We have throttle, steering, and suspension. So now,
talk about how you turn those off and on real quickly. A lot of people don't realize that's a tool that's available for them.
Yeah, this one is super helpful. I don't know how many times I found myself with my laptop up on the roof of the car and I'm in the back of the car trying to do something. I can't see if I'm changing it. So all you have to do is click on the channel and it'll turn them on.
Where you get that nice big panel off to the side. And if you're old like me and your eyes aren't working so well, it sure is nice to be able to have that channel value just being projected out a little bit bigger for you.
Right, it sticks it over here on the right in big letters, and you can see this across the garage as you're doing it. Or if you're like me, and sometimes I have a 7-year-old helper, if I'm at home, or a 5-year-old helper, they're doing things and I'm not really sure they're doing it right. This is a way I can see it from across the garage. And what's pretty neat now, Roger, if you spin that steering pod a little bit for us.
So back over here into the live picture, you can see that's here. I put a little arrow where 0, like the piece of tape on the top of your steering wheel. So if I turn that thing about 90 degrees to the left, there's what you're seeing on the main screen, right?
Right. So now you can see it pops in here and it gives us the 90-degree measure. So we know we're working on the right channel. It's a nice little way to check things out. And then now if we go in and our calibrations are up here. So we can do auto calibrate. And if we click that one, because one of the great things with the aim stuff is we can always exit and not change anything and mess it up. So here we go, geez, we wanted to do steering, but I don't see my steering in this setup. So we're just gonna exit. And we didn't do any harm, we didn't cause any problems, we got right out. The next button that has 2 points, which is the idea we talked about steering, is that we're gonna set some limits in here, and that's this button. And when we come in, we're gonna say we wanna set steering. So now, as we go to calibrate steering, and what I want you to think about is as we do these, this is going to be through a number of different sensors. Anytime we set up a sensor, if it's angle, it's going to be this kind of thing. So right now we're doing steering. Maybe what you'd be looking at later is a sway bar position, or maybe it would be bell crank position. This is the idea of what you might set up with some of these things. So we can see here that because we put in the 90, it auto sets our setup to 90, minus 90, 90 left, my left, and then 90 positive. And we can see where the sensor is right now is right here. So if Roger turns that wheel for us 90 degrees left,
just like you would in the car, you would turn it 90 degrees to the left.
yep, we can set our point A, and it tells us point A. We can say set point A. And the other neat thing in here, and we saw some questions about setups with people doing some things with different millivolt values I saw in the chat and everything, and it gives us this millivolt reading here. So now if Roger turns 90 degrees to the right,
you can see the little black arrow, and I'm just pointing at 90 degrees, just like you would your steering wheel.
And we see our millivolt values change. Our degrees, because we're not calibrated, goes to something kind of crazy. We can say set point B. So now we have our 2 points, and we can save our config, or not our config, but our calibration. So now we see that it says our wheels 90 degrees to the right, and if Roger shows that video, it was 90, and as he turns it back to 90 left.
And it doesn't just stop at 90, like Matt says. I can go all the way down here to 180 degrees to the left, right?
Right.
As you can see there now.
So what's important there is to pick numbers that you can produce when you go to calibrate. So don't pick 87 unless you have some sort of inclometer on your steering wheel rigged up crazy. But that kind of precision usually isn't needed for a driver improvement. One of the other interesting questions I saw in there, someone said, is it steering wheel angle or is it wheel angle? That depends what we're looking for. I always calibrate my sensor to steering wheel angle that I hold, because when you're talking to a driver, he doesn't know where the wheels are pointed. He knows I turned this much, and we can work with this much, right? Then if you want to do the math, if you're doing some math channels and you're trying to calculate steered angle versus the Ackerman angle versus how much understeer the car had, all that kind of stuff, then you can do a math channel and figure out right where the wheels are. And there's some great ways to do that. But I think I always calibrate to steering wheel angle because that's what's relatable when everybody looks at it. And I think, Roger, you probably do the same, right?
I do, and again, it comes back to these data systems are very definable to what you want them to do. So most of our users are trying to do driver performance things, and they're trying to help themselves understand what they've done with their steering wheel and what the reaction of the car was. So steering wheel angle is really the right thing. But if you're working with a team that is developing a new race car, and they really need to know spindle angle, or of each the left and the right, then you set that up that way, right? So that's more important to them. So keep that in mind as everything we're doing here is think about what information you want at the end of this process in your data to be looking at, and that's how you set it up. There was a question there on resolution. We only selected the 90 each way. You can do 180 each way, but the resolution us using such a small number is not that big of a deal. It's more the resolution of the sensor itself, where if you had a sensor that has a a very small resolution, or versus a super super high resolution sensor, that's where the resolution problem comes in, not in the calibration here, because we're only looking at it to the nearest degree the way Matt has set it up. So we're going to be okay on the resolution. And one last thing before I hand it back over to you, you'll notice in the chat that Robbie has linked a document that what has he mentioned, for those interested in documentation for this, obviously you'll be able to watch this video back and see the exact same steps, but there is a PDF document that Robbie has linked for calibrating, for setting up, going through all the steps Matt did, and then how to calibrate, which buttons to push, and all the stuff that Matt went through there. Those instructions as a PDF file. So that'll be downloaded, and Robbie will include 2 more as we do a throttle one and a suspension pot one. We have documentation plus the video we're building here. So everybody will see that in your notes. Go ahead and click on it in the chat. I'm sorry. Go ahead and click on that as Robbie does those, and you can download those locally right now, and they'll be in the description box of the YouTube video once we place this up. So. Perfect. There you go, Matt. What's your next one?
Yeah, and I was to finish that off really quick is one to Jeff's question about the reading is some of that depends. If you have a rotary sensor, they make 1-turn rotary sensors. They make 3-turn rotary sensors. I don't know which one Roger has there, but the more turns, the less resolution will give you for just 90 degrees. So it's something that gets into choosing your sensors a little bit. In doing steering, the rotary position sensor one is really popular. The other really popular one are these string pots, because you can mount the sensor, wrap this around your steering wheel, and it gives you a great, simple way to set up your steering position. I've had questions about the precision on them. They work great. They give you great precision. Working with engineers up to the NASCAR level, I've never had someone have a problem doing it this way.
As Robbie just mentioned in the chat box as well, the one that we just did is a 10-turn or 3,600 degrees for that 0 to 5. So the resolution, this is a fairly inexpensive sensor that we just used. But as you can see by the numbers, just looking at here, they float around a little bit because that resolution's fairly high. But you're certainly getting data that is very much usable for your use typically.
Oh yeah, completely. You know, the difference between if you turn the wheel 89 or 90, what you really want to know is when did you turn in, right? How much did you turn in? What's the order of magnitude? Not did you turn in at 1 degree or 2 degrees, right? That's exactly. When you turned in early, you turned in early. So I think great question. And then we just have to kind of look at it in the scheme of how important is that fine increment to what we're trying to accomplish. But next, I'd like to jump into the throttle position sensor. This is another one, and I'd say even more important for driver improvement than working with steering, because we want to know, did you really hit the gas? Did you do it? Were you coasting, right? One of the words that keeps coming up in a lot of these seminars, coasting. Were you coasting in? Were you on the gas full throttle, right? Maybe you have a big horsepower car and you weren't quite there yet. So the idea is going to be really similar. What we're going to do is we look and we see our calibration area, and we're going to say throttle position. Throttle position is one of the easiest sensors to calibrate, because all we really need to do is set 0. And I always think, I know it's probably backwards for you guys, I think 0 to my left and 100% to my right. So the way you're going to set these is oftentimes I climb in the car, or if it's a race car with big NASCAR bars and it's hard to get into, one of my tricks is I go find the broom that the team uses to sweep up, and I can get the throttle pedal, sticking the broom in the car and pushing it down so I don't have to climb in. But we go on here, and if we're at 0 and we can see we're at 0, and maybe Roger can point to the sensor that he has for throttle position.
This is the one I have set up and mocked up for throttle here, and it's just a rotary pot, like somebody would have a little bell crank hooked to it for the throttle position itself. So we're at 0 right now, as Matt said.
So we can go in, we pick our set point A, the first point. We can go to 100% throttle. So you push the gas down all the way, and we're going to see Roger turn that. We get 100% out of it. and we say set point B, and then we save. That's simple. And what we can do now is if we want to double check that, and I always suggest we double check. So I clicked on throttle to get the big reading for us. I'm going to turn off steering because we're done with it. We see it's at 0. And now, Roger, you can work that sensor a little bit. And we see it varying between 0 and whatever that number is. For folks with older cars, sometimes when you get a wearing throttle cable or you start having some troubles, it's a good opportunity to check this. Make it sort of one of your projects when you're in your data. Look and say, is this 100% or is it, are we always getting 100%? If we're not seeing 100% all of a sudden, we go, well, why aren't we? Interesting one, I had a number of years ago, we were at a big oval track with real high G-forces on the cars and everything. And I was giving the driver a hard time. I said, you got to be flat through that turn. Turn 3's got to be flat. And he said, I know I am. And I said, oh, the data says you're not. So the next time he came out and he still wasn't flat. And I said, you're not flat. You got to be flat. And he goes, I know I was. I had both feet on the gas. We went through, we checked the sensor and everything, and the car was twisting. So a good way to check your data and to look through it and see what's really going on, because sometimes it leads you to something else.
And Matt did not go through the absolute configuration of that throttle, and I'm not sure if you are going to, but either way, Robbie will throw up a link to all of the steps to set up a throttle position under the channels tab.
Yeah, and I think maybe we'll skip that one in the interest of time to make sure we get the final ones here.
Perfect, no big deal.
And what we're going to do is we're going to jump back to our configuration quick, and we're going to look at the suspension setup, because this is one, if you have these sensors or you're trying to really calibrate your car, or sometimes I refer to it as your butt dyno, you're trying to calibrate you to what the car is doing, is figure out how things are feeling and everything. This is a good way to do it. So here we have it set up as Roger went in, we typed in front left suspension, analog channel. For suspension position, we choose a position sensor, right? And then we can go in and choose position. And then this one, I always go with auto calibrate, because at the bottom of the screen, what we see is we pick the travel of that sensor. So this one that I have is a real long one. This is 150 millimeters. This one is 100 millimeters. The one Roger has on there is 50 millimeters. It's a short one. Maybe that's a motorcycle sensor, right? Where it's a little bit shorter. We tell it how
it's
long.
Actually fairly used. That one there has done a lot of miles on off-road race trucks and drag cars as a gear position shifter. Gear positions sensor is what that one has come from. You can see some wear on it there. So that's why that's a short one here, but it goes really well onto the little demo rig.
Yeah. So we set it up as an auto calibrate. We talked about suspension, 200 Hertz, 500 Hertz, where you want to be in there. Unit of measure here, we picked millimeters. We have a 50 millimeter pot. You can change this over to inches and it'll change it. That's a 2-inch sensor. A great way. And then if we're doing suspension, maybe we want decimals. Usually we would. And then we would save it. And I'm not going to save it here because we're not going to transmit it over, because we have that in our stuff. We're going to go back to our live measures and change back to our suspension sensor. And as Roger moves that, we're going to see this value change as it reads through the sensor. And if this is the suspension sensor, when the car's at ride height, that value is going to be, the sensor is going to be somewhere in the middle of its range. So if Roger picks somewhere in the middle,
let's put let's put it about there. Let's say that's ride height sitting on the scale pads.
Perfect. We can go, and remember this one we picked auto calibrate, different than the previous two. So now we're going to pick auto calibrate, and we go, and it's a little tiny bit different, as we can say select all. And this is a feature I suggest you do at the beginning of your event when the car's on the setup pad or a pretty level surface, because that's going to set all your accelerometers so you have good data coming out of them, and all your roll rate, your pitch rate, all the gyros in there. It's going to get all those right.
And you can see here the values of the accelerometers are not zeroed out right now. So it not only needs the suspension set, but it also needs all the accelerometers and the gyros too.
Yeah, so we're going to do one and then we'll do all of them so you can see kind of both ways. This one, real easy. We have our set button that comes up when we go over that one. We click set,
Bink.
it sets it to 0. If we want to set all these sensors, and it's something I suggest you do, we say auto calibrate all. And now we see it set up our inline, our longitudinal acceleration, our lateral acceleration side to side as you turn that steering wheel, and vertical. Vertical one's a neat one to look at if you're in there. So now that we set them, we can exit. And now we see Roger hasn't touched the pot and we're at 0. We're still at that ride height sensor. As he moves it in and out, we're going to see it changes.
And now the 0 is where we just did the 0 set. And now the suspension's going up and down as he's hitting bumps and things on the track. Yep. Everything looks good.
So typically the most common thing we see with suspension sensors are these linear pots. It can be done with rotary if you have maybe a Formula car with the bell crank, or you get pretty creative and you mount it on the A-arm so it rotates with it. Popular one, and I think Roger was one of the first people I heard it with, is he has a great story about taking a suspension position off of, what was the car, Roger?
I'm not sure where the story's going, actually.
Oh, when you and Andrew had the Miata and you wanted to know
yeah.
the bump stops.
Yeah, we had a spec Miata and we had suspension sensors on it, but and some people were thinking maybe we were cheating and playing with shock sensor data because shocks are specs, so you can't do anything. But what we were actually looking for was a ride height sensor, and we were looking for when that car was hitting the bump stops, especially on the right front corner at Topeka, Kansas, on that particular track. And we were doing all of our ride height adjustments, all based on some math I had done ahead of time and knowing exactly when those A-arms were touching those bump stops, and it shortened up the amount of work that we had to do and to get the car right very, very quickly. And again, so while it is a suspension sensor and it was measuring it, we were not doing histograms and velocities and all the different things. We were using it for a very, very accurate ride height sensor. It was kind of a cool way of using it.
Right, and maybe we can throw up the other poll, Roger, and I'll talk over it just for a minute here.
Okay, the last one we have here is future webinar topics. Is that the one you want to look at?
Yeah.
Okay, let me launch that as we're getting a little bit closer. There you go. Again, it's this one is the most important, or the one that we use the most when we're looking at things. Give me your top 3 topics. I mean, it's a multiple choice. You could cheat and do a couple of extra ones, but I'm hoping you'll just give us your top 3. The sensors have been up in that list, as well as track maps, and of course data analysis has been important to a lot of people all the time. So, but sensors was up there in configurations and calibrations. So, which is the reason that we kind of moved this webinar ahead. We had always been thinking of doing this one, and it's interesting as we moved it ahead, and we've got one that we're going to be doing, we'll talk about in a moment, for next webinar in a couple of days on Thursday. We've moved another one ahead. So everybody's taking a look at that. You have anything else to add while we let them finish that up? We'll probably go another 15 seconds or so on that, Matt.
Yeah, I think just as people keep putting in here is the point of me bringing up Roger's story about using the different sensors, and I see someone said they use a Jeep Cherokee sensor, and people use some different stock sensors that they can get to, is think about using these custom sensors in different ways. So it's not necessarily just say, well, I don't know how to do the shock stuff, or I'm not going to get my shocks revalved, but you go, well, I don't know how high my car is. So maybe that's what you're looking at. Or one I work with a lot is if you have a car with a splitter or something on the bottom where it starts to bottom, maybe you only really care about is it hitting somewhere, or you're trying to find something binding. I know one of our previous guests was James Clay, and what I loved, this is an old story about James, and I wish I could find the article again. They took one of these string pots and put an extension on it and ran it between the shock towers on a BMW to see how much the car flexed. And I thought, wow, wasn't that a cool way to do something a little custom and try to figure out what's really happening with the car? Because we have such a powerful device. Let's harness that. And instead of guessing what's going on, let's put a sensor on and measure it.
Yeah, that's a great example. I took a 200 millimeter linear pot like we have here for our shock sensor, and I was working with a Formula Continental team. They were a tube frame chassis, and we were putting stiffer and stiffer rear springs on it, trying to get the thing to do what we wanted it to do, and the lap times and the driver feel it did not change. So we finally put the engine was actually a stressed member in this the way these cars were built, and so we put a sensor from the top of the roll hoop right behind the driver's head down to the rear suspension member. And the car was flexing so bad, and whenever we'd put stiffer springs on, it would just flex the car more. And that shock pot, that linear pot, was giving us that information. So again, it's a sensor. It's not just a shock sensor, but it's a sensor. So everybody keep in mind as you're thinking about how to use these different things, all these existing sensors, what's a way that you can get better value out of it? When you're looking at your data, boy, I wish I knew X, and how can I put a sensor on it to know more about what I or my car is doing? And that really is super valuable. Let me end that polling, and let's share it. Everybody can take a look at it and where we are. The data analysis, again, 68% being the biggest one, which has been a very consistent thing. The next one is configurations. We've did a little bit with configurations today, so that's kind of cool. And the one that was at 42%, and then CAN expansion, talking about how do we expand AIM devices and use some of the tools that we have, some of those expandable devices via our CAN network. That was at 31%. I think that's as high as it's been the entire time. So track maps is right up there at 28%, and ECU protocols. Some more folks wanting to learn a little bit more about that, so those are in the hopper as well. So thanks everybody for voting for those. I really do appreciate that. So I'm gonna stop sharing those so they get there out of your way. And Matt, go ahead and take us to the last topic I think that you have.
Perfect. So now we looked at some of the really easy sensors that people use a lot. And the next two, if you understand how those work, the next stuff is really easy because it's us inputting some data, not having to kind of create everything. So now we're going to make our own sensor. Say you have I'm going to start with an easy one. You have a pressure sensor from another manufacturer. It was already on the car, whatever it may be. My personal favorite was someone said, I had another data system and I want to upgrade to an AIM, but I have a sensor and I want to use it. So we go into this, I always think it looks like a temperature symbol here, and it's the custom sensors. And in here, we're going to make one. We're going to say how to make a new pressure sensor. And I'm going to give you a couple pressure webinar. We can type in a name. And one of the powerful things here is if you make a couple of these, or you're trying some different things, put in a comment with it. So we're just going to put test. And that way, if you're like me and you make a whole bunch of them, you can't remember which one you wanted, now you have a note with it. So this is how we make a custom sensor. We can come in here and it gives us the same sort of options we had before. So measurement type, we're going to pick pressure. So we have all this range, all the ideas that you come up with that you could do something different. Look at this list and maybe it gives you an idea how to measure something on your car to improve things. So we pick pressure. Calibration type, this is what usually gets people. If it's a pressure temperature, we're not setting 0. That's set in a chart that the manufacturer is going to give us. So we're going to pick none because there is no calibration. We get a millivolt table because the AIM device has taken voltages. And this is something that I think is going to help a lot of people. Your typical pressure sensor is going to be 0.5 volts at the bottom of its range. 0.5 volts is 500 millivolts. So we're going to put in that 500 millivolts.
Yeah, everything in AIM is always in millivolts.
Right. And you can see it's labeled here, millivolts, milli being 1,000 per volt. And we get to pick our measurement system. I had a customer recently had a European bike, a beautiful Ducati motorcycle that needed a specific sort of sensor to thread in correct. And he went in and bought another sensor so it would fit the thread. I helped him set it up. So his sensor was calibrated to bar, but it doesn't matter whatever you pick as long as it matches your sensor. And then we pick 0 PSI. And typically your pressure sensor is going to be max scale 4,500 millivolts. and say this is a 100 PSI sensor. AIM draws us this line and sets it up. Now all we have to do is save it. So here's something, and here's a little trick for a lot of people, is a brake pressure sensor, 0 to 2000 PSI is a pretty big range to put in a 5-volt output. And sometimes people will say, hey, my brake pressure at 0 volts or at 0 pressure is reading -2 or -5. We used to see that a lot with other manufacturer sensors. AIM has started to make their own sensors that have been, in my experience, really great, and we don't have this 0 problem. But if it's off a little bit, you can go in and change this number and say maybe it's 491 is the 0. Save your sensor and transmit it to your dash, and then it will offset that a little bit, and you can change it so it calibrates that all the time. It'll be right in your data, it'll be right in your Smarty Cam, and it's a nice little trick to have in there.
Yeah, you see that a lot. Brake pressure, obviously, it's a big range, 0 to 2000, right? But let's say you're using a lot of the off-road trucks and some other things are using a fuel pressure with a carburetor, and that fuel pressure is critical, and they really do want to that 1/10 of a degree, a 1/10 of a PSI to be pretty darn accurate. And so what you do is you can hook that sensor up, and before you even build a custom sensor, go look at what the millivolts are when it's sitting there at 0 PSI.
Right.
And even pressurize it up and have a mechanical gauge if you want to the first time, and find out that it's running at 7 PSI, and then come and find out what those millivolts are. Come in here and build your nice cool little sensor, and then from then on you have calibrated your own sensor very, very accurately. So Matt's right on the money.
And I see 2 comments, one from Todd here and one from Keith. Keith had a great question. What if it's not a linear sensor, right? What if we have more values that aren't?
The last one we're going to do is actually going to be
the next one is, and what's so cool about AIM and this stuff being so powerful is it doesn't care if it's linear or anything else. And we're going to see that in the next example. The other great suggestion from Todd that I should have mentioned, but he brought it up, is if we go into live measures, and I'm going to use throttle position because we have it. Is right now we're offset, say 5 millimeters. Pretend this was something else. We can click this millivolt button right here, and it will tell us that that millivolt value equates to this distance. So if we have a brake pressure that's reading off of 0 just a tiny bit, we can go to live measures and get that millivolt value to put in our, I'm going to hop back to custom configuration, to our custom sensor. So now we don't have to guess what that 0 voltage is. We know exactly what it is. It's a great way. It's a question that used to come up a lot. It doesn't come up as much anymore. But if you want to offset things or do that, you can do that. If you're making a custom sensor, this is where it is. Hopefully people see that pretty well. And then I want to jump into our nonlinear setup. And
the next one up. The next one up.
There you go. Another question here. I'm going to close this quick. Somebody asked, and I think the guys answered it. They said they didn't have any custom sensors here. Well, these are all the custom sensors Rogers built. Until you build them or you import a sensor from somebody else, you won't have any there. Another cool feature with the new hardware is that it will automatically import any custom sensors that are in a dash. Great feature. So here we look at this one, and for folks that aren't too familiar with it, linear is a straight line. And we can see this one, it's not perfectly straight. So here's your example, not a linear sensor. A great way to kind of look at it here. And what we have here is this is a E36 custom fuel sensor that Roger set up. And the way they set this up was they started to take the values, and they probably, I'm guessing here, but they probably started the car empty and they added a gallon of gas. And then they took a millivolt value reading, right? So when they added a gallon, it jumped to 1084. And because Roger did tell me this part, he said what they also did is they ran the car with a gallon in it until it wouldn't run anymore. And they found it was 834 millivolts, and they put that in as 0. So when the dash read 0 is when the car shut off. It wouldn't run anymore. But they started 0 tank, added a gallon right here, and it read 1084 millivolts. And they added another gallon of gas, and they got 1466. And they did this all the way till the tank was full at 16 gallons. And the software develops this curve. And in this curve, we now have our fuel volume in our fuel cell. And we know how much gas it is. Really cool feature for folks that are looking to add the fuel level, because sometimes we put a dash in and it blocks that part of the OE dash. So when we save this and close it, and this is the same thing that we would do in the other one, is when we're in our config, we can apply this to a channel. And we didn't do that before, and we're going to put that in here now for you quick as we start to wrap things up. And we're going to say fuel level for this channel, and our function is going to be volume, and we can choose fuel level. Fuel level is one I look at, and in the sensor, we're going to pick our custom E36 sensor that we just made. In here is AIM added some really great filtering to fuel level measurements, so that we don't have to try to read the slosh as the car turns and the gas goes back and forth. I always log fuel level as slow as possible, 1 hertz, 1 time a second. The next part is it says units of measure. I work in gallons. If you work in liters or gallons in the UK, that's fine. I wouldn't.
Critical, you need to base that on what you set up your table on, obviously,
right,
to your custom sensor.
Yep. I would look at 0.1 decimals. I would like to know if I had,
tenth of a gallon, yeah.
Right, 1 gallon or 1.5, I think is important. And then the filtering is a pretty powerful one in here. Is these filters will take out a lot of that slosh in it. And by default, I don't trust the gas gauge as much. I'm still really a pump out kind of guy, that I always go to the biggest filter. So it makes that data as level as possible, because the range of tracks we go to from Lime Rock to somewhere else, the fuel can spend a lot of time out. So we try to filter that out. And then we would save this sensor configuration and transmit it to the dash. And now we have that custom sensor into our dash to read while we're driving. So hopefully that kind of answers a lot of the questions that people have around these custom sensors. I think we covered a lot of different varieties, but I think once you understand how the steering and the throttle position and suspension ones work, after that, if you have some other sensor you got from another manufacturer, once you have that calibration table, you go through like we did on the fuel or the pressure, the rest of it falls into line pretty quick and easy. So, Roger, do you think there's anything I kind of missed to tie that all together for folks, or what do you think?
As I was watching along, I think you hit on everything that I was hoping you would hit on. That was perfect. It was good.
Good. Sometimes it's presenting everything to keep it going. Well, it's hard to see the whole chat and the questions, but the guys do a great job at nailing everything that I miss.
So what I'm going to do is I'm going to jump back and reshare our presentation. Jump up one slide. Oops, not that way. Your other up. And we do have just a couple more questions, Matt. If you'd look at those for a quick second. And is there any way to filter only the data sent to the dash and not data recorded for later analysis? Sent to the dash. You're going to get both, right? If it's sent to the data logger, if it's either filtered in some sort of a filter device on, let's continue to use the fuel level. There are some devices out there that will smooth or anti-slosh that data coming ahead. When it gets to the AIM, that's where we're getting that final product. So if it's coming that way, it's already done. If we do it as it comes in with the process Matt just talked about, of course that'll be the way it looks in the data. So all available for later analysis.
Right, and Jeff also brought up a good point in 2 ways. Is that I said that the dashes can take 12 volts in. That's really something for the new dashes. Your MXL2, MXS, MXGs, MXPs, MXMs, Evo 4S, Evo 5. Those can take the 12 volt input. And the older, the MXL Pistas and the MXL Pros, those only take a 5 volt input. If you put 12 volts into them, you're going to do some damage. Also on the older dashes, as you're trying to set up some of these custom sensors, is remember that channels 4 through 8 are wired for 12 volts. If you put a pressure sensor on channels 1, 2, or 3 on an MXL Pista, it will not work. And you're going to call in and think that you have a bad cable. You're going to go through a whole bunch of stuff to find out it was simply on the wrong channel. So an important one to remember.
Okay.
Someone said they didn't get the smoothing fuel level answer.
Take a look at Chris. We don't have time to go through it again. Take a look at the video.
Yeah.
If you still have a question, write me an email. You'll have your contact information in a minute. I think I've got a document that walks through a lot of those steps as well. So if you missed it, drop me an email and ask for the fuel level smoothing document, and I'll send you something in an email.
Right. And I think the other questions that I keep seeing come up now are really kind of specific to your car and your wiring in particular setup. So I think those are the ones that are probably best emailed in to give us the specifics of your application so we can get.
Perfect. Okay, let's jump to the next slide where we talk a little bit about the training and support. We've got all of these videos, all of these webinars are heading out to YouTube. Try to get it up within an hour of when we finish here, but there is a ton of other ones. We have over 70 videos out there now, so lots of other information, if including some of the stuff that some of the questions that were coming up today are already videos out there as well. So take a look, peruse around out there and take a look at some of the different things and see if there's something that might help you beyond what we're doing here. Customer support, we're out there. We're starting to get back out to the track. I had a local race here at in my area this weekend. It was the first one that was local, so that's pretty cool. I know that a lot of you folks that I seen either on Facebook or dropping me texts or emails, and we're at the track this weekend for the first time. So we're extremely happy about that, and we're looking forward to being out there with you. If you don't see us, give us a call at 800-718-9090. We're more than happy to take your calls. The next webinar, this one is going to be pretty. They've all been super interesting, certainly, but this one will be kind of fun. We have talked about it in the chat a couple of times in some of these webinars, and we placed it out onto our website, and some of you may have seen it there. And I know 4 or 5 of you that I know are in the chat here today talking have been using this. But we're going to talk about it in a couple days. Thursday, May 28th. James Colburn is going to come back because he's been doing a lot of testing with motorsport simulation data coming out of, in his case, iRacing. And we're going to talk about how that works and being able to bring that data now directly into your race studio universe. It seems to be working very, very well. We'll have some learning curve here, and we have to tweak a few settings and some other things, but the actual bringing in of the data is working flawlessly from what I can tell. We're also going to talk about not only the software and gathering the data and then bringing it into AIM Race Studio 2 analysis right now, in the near future into Race Studio 3 analysis, but also the ability, and hasn't been talked about a ton by some of you, but is the ability to place your AIM hardware. Here's a mocked up sim rig right here, and the guy's out driving, and then they've got an MX, looks like an MXG on his dash here. You can take your AIM device, certain ones, if you go onto the website, you can see which ones is capable. It's pretty much mostly the current hardware, and you can actually have your dash in your iRacing rig or your sim racing rig, and wire it up in just a simple USB connection, and set the ECU protocol to it, just like you would with your gauge, and all of a sudden that gauge is working exactly like it would in your real race car out on the track. The shift lights are working, the predictive lap timing is working, all of the different settings, RPM, speeds, just like you're out on the track. So that is a very cool thing. Is we're allowing or giving you the ability to connect your AIM hardware to your sim rig, and then when the session is over, grabbing that the data and bringing it into Race Studio and being able to analyze your data in something you're very fairly useful with. Is something you've been using quite a bit. If you're here at this webinar, certainly you've been using Race Studio to do your analysis, and now you can bring your sim racing rig data into Race Studio 2. iRacing, a set of Corsa, and rFactor 2. rFactor 2 is just 2 or 3 days away from it working. The other two are working currently and doing very well. So that's what we're going to talk about in some more detail on Thursday. So looking forward to seeing that and having everybody drop by. So perfect. The again, I thank you. There's some contact information. I've mentioned a couple things I might send out. There's my email address, roger@aimsports.com. Matt's information is there as well. If you have some questions about something that he covered, go ahead and drop him a note. He's always happy to chat with people. Thanks, Matt, very much for doing this. I know this was one where it was there was some preparation needed, and I know it took you a bit of time, so we do appreciate that. Do you have anything else you'd like to add as we're kind of closing this up?
No, I think if anyone has any questions that are kind of maybe specific, or you have an idea of what you want to measure, shoot one of us an email. And I can't wait for Thursday to get ready for my sim rig.
Yeah, it's going to be pretty cool. Thanks to all the AIM guys in the back there that have been answering questions like crazy. I see, gosh, 45 answered Q&A in the Q&A box, plus just a ton in the chat box. The guys work hard, and you guys throw a lot at them, and we all appreciate it a lot. So thank you very much. Looking forward to in a couple of days with James. And Emiliano is going to be here chatting with us. Emiliano's been helping in the background. He'll be co-hosting for this for the iRacing or the sim racing content as well. So thank you very much for being here today. And that's it for today. And we will see you on Thursday.